G'day folks, we have another autopsy victim on the table. This time it is a burner and gas valve assembly from a instantaneous water heater. This one came out of a large Bosch instant water heater. This is one of three that I scrapped a while ago. One of them was an Everdure type, and there were two Bosch units. The Everdure one I quickly opened up or separated the brass valve and found that the diaphragm was blown. And this one here, I have no idea, but we're going to do a full autopsy on it instead of just breaking it in half. These work off of flow of water. When you turn the hot tap on, water flows through the valve body, pushing a diaphragm up. Diaphragm opens the gas valve. The pilot light up here ignites the gas coming out of these burners, and there's a copper coil, a finned copper coil, a large heat exchanger which you'd see in the previous video. I'll try and find the link to that one, put it in the description. The heat exchanger has the water flowing through it, and you get instant hot water by the time it reaches the end of the coil. That's the basic design behind it. It's a nice design. You do lose a bit of water during the heat up period, but once you're running it just runs continuously. Not like the storage type tanks which constantly reheat and less efficient, but I think you just get hot water a little bit quicker. That's about the only advantage, I guess. It's got a little Piezo Igniter on it and various settings. I think that's off, low and high, and that's about it. There's not really much else to it. And that's for the igniter. I don't think the igniter's even in there. Oh no, there it is, yeah. But anyway, we'll open this thing up and have a look at it. Starting with, I think, the water valve. Oh no, sorry, we'll get the burner rack off and have a look at that. The burner rack's pretty straightforward. Got an air inlet screen and just draft type inlet for the pilot light. You can see up there a little housing there which acts as a air inlet draft tube. And there's a wax stat type thermocouple which is actually blown open. I guess that would explain the failure of this unit. Yeah, the little thermocouple there is blown open, or the stat. And where does he go? That's electronic actually, it's not a... is it actually? There's an electrical sensor there, and there's also... You might have to pull him out to find out, but that's definitely got a hole blown in it. That's not normal. And that dog next door sounds like it's having a bloody seizure. It does that from time to time. Yeah, I'd say that blown couple is the problem. Oh, it looks like there's a lot of corrosion there as well. That might be leaking. Although that's gas though, that's not water. A bit of condensation damage there. Yeah, I'd be willing to bet that's the only thing that failed on it. But hey, roadside finds are roadside finds. Who's going to complain? So yeah, I'll break this into three pieces. We'll have a look at the gas body, the burner rack and the valve. How about that? There's a lot of little bits on this thing, and I don't want a 30-minute video to try and upload, so let's keep it simple and straight to the point. Okay, well that breaks down into some pretty easy component groups. We've got gas inlet pipe, the gas burner rack, nice little jets and everything on it. I'll have to connect that straight up to a gas bottle and see what kind of flamage we can make one day. I won't destroy that. We've got the valve body that the burner rack screws onto at the top here. Gas comes in through there. And we've got the water valve which actuates the gas body. It's also adjustable by the looks of it. So, yes, we shall start from top to bottom with the burner rack, which is pretty straightforward. You've got the gas coming in through there under pressure. The jets fire into the centre of each of those mixer tubes, and well, when you inject a jet of air into the centre of a tube, the high pressure discharge creates low pressure behind it, and that draws air in behind it, so it's actually drawing air in from underneath. That's what all the holes are about, and mixing the gas as it goes through the tube, so you're not getting straight gas, you're getting a mixture of air and gas, which then comes out through the slits in the top and burns off. So that's the point of even your common barbecue, your gas grill. If you look at the way the burners are set up, you've got a gas jet aiming into the center of a big open tube, and that jet of gas creates a low pressure behind it which draws air in. It's also the same principle behind the Lewis machine gun's cooling jacket. It looks like a big fat water cooling jacket, but it's actually a air cooling jacket with long heatsink fins along the barrel. And as the bullet leaves the barrel, that blast of gas coming out of the muzzle creates a low pressure behind it and draws air from the back of the jacket all the way through. So it's actually creating the same effect. It's a really neat design. It's bulky and ugly, but it works. So yeah, it's like an air vacuum. You stick the end of an air nozzle down a tube and discharge it, like a large diameter tube, you'll actually get a larger volume of air coming out the other end than you're putting in with the air gun for the same reason. That's how air vacuums work, and this thing's doing the exact same thing. So there's a little bit on your average gas burner rack, and that can be applied to pretty much all of them. Whether it's a big, I suppose you'd say industrial size heater, or your average water heater in the home, or a gas grill, a barbecue. Same deal, they all use the same principle. Mix air, high pressure jet of gas, air drawn in, mixed and burnt as it comes up through the burner tube. They're really nice. So let's move on to the gas body. Okay, so the first part of the gas body that I'm breaking into is to do with temperature regulation. There's a little alcohol stat probe that was attached to this body here, and it's also got bellows on it, as they usually do. So as the water temperature at the top of the coil gets hotter, because the alcohol stat went to the side of the coil body, as the water temperature gets higher, the pressure on this bellows increases, and it actually regulates the gas pressure going to the body. So when it's cold, it'll be putting a lot of pressure on the body and increasing the gas pressure, but as soon as the water heats up beyond, or approaches its maximum operating temperature, the pressure inside the wax or alcohol stat increases, and it turns the gas off by itself. So that's part of its own safety regulation system. It's got a nice little alloy casting, and that's about it. Little copper bellows. Again, I'm not really interested in scrap metal at this point. It's worth bugger all at the moment, and not really worth my time to pull it out, so it all goes into the same bin. The scrapyard guy gives me a lot of stuff for free, so I'll repay him by dumping this stuff in his bins for free anyway. It's a, I suppose you call it a fair trade agreement, something like that. Outside of this, we'll disassemble the rest of this body. That's the feed line for the pilot light up there. That's not actually attached to that tube there either. I'm thinking that's to do with air resistance. It might be a resistance based thing, because there was also a wire going to it in there. So I'm not too sure how that works, but we'll find out. Anyway, let's remove this. Okay, so taking the pilot temperature sender, or I suppose activity sender, off reveals the main part of the gas body and also a filter screen. Yeah, because that's coming through from here, which is in turn connected in through the intake. This is the inlet. So you got an inlet filter, which is actually remarkably clean. Normally you get a lot of yellow crap and gas pipe tape and stuff stuck to them. It's the first time I've seen one this clean. Yeah, see, that's a stat. Evidently there is some kind of pressure sensing on it. Not too sure. No, there's actually a copper coil in there. Or some kind of solenoid. It's odd. It's electrical, or whatever it is. Yeah. It must be electrically isolated. Yeah. It's an electromagnetic coil. It's a yeah, electromagnet. Huh. So it's not actually a pressure stat, like a wax stat or something. It's a electrical controller, electromagnet. So that's your gas shut-off. When the pilot is hot, it must stay open. As soon as the pilot cools down too much, the current flow to the coils decreases, so it closes the gas off. The pilot goes out, it shuts the burner down. No gas explosions and unwanted fires. And that is gas flow. That's gas flow to the burner rack. Burner rack screws on the top here. That's a valve, spring loaded, of course. I'm guessing it only releases once there's back pressure. It's a fairly tight spring though. Oh no, sorry, this is also piloted by the pressure from underneath. Gas pressure is not enough to compress that spring, no way. So without water flow, this spring is strong enough to push down and seal gas off from the burner. So that, as long as there's hot water in the, or sorry, no water flow going to the heater, or going through the heater I should say, as long as you don't have a hot water tap turned on in the house, this is bearing down on the seat and shutting off the gas. You won't get the burners to run. But as soon as you turn on the tap, pressure from this, or flow from this, pushes a pin inside up, which pilots this upwards. So if I pull that out, yeah, there's a spindle in there which depresses this valve. So water flow occurs in the water body, the water valve. This opens, gas rushes through to the burner rack, and you got fire, you got heat. Turn the water off, this closes. No gas, no fire, no heat. Really straightforward. It's pressure differential again. It's just a pressure differential valve. So got a spring, another little acetal seat, and that, yeah. And that's what operates it. It's fairly stiff, but it's there, it works. Then it probably has fairly tight seals anyway, since it's sealing between air and water and then gas, so you've got to have some fairly stiff seals. And our mains pressures average about 80 to 100 psi. And yeah, that little pin in there, when water flow occurs through this valve body, that little pin inside will pop out, depress that, and allow gas through to the main burners, and away you go. So that's really simple. I'm learning as I go. It's always fun. I hope you are too. This video is going to be fairly long, and that's a good thing. I'm working tomorrow anyway, so I might start the upload in the morning. It's the one thing I hate about where I am. Uploads are slow, and that's why you don't see so many long, detailed videos. I get requests all the time for really long, detailed videos. But unfortunately, I can't really upload a couple of gigabytes without something failing and destroying it. Which is a pain in the ass, because I wish I could. I need fibre optic. I'll shell out some money and see if I can get fibre optic installed. Then we'll be cooking with fire. No pun intended. Anyway, let's finish off this gas valve. It's high, low and off, and Piezo Igniter, and the Piezo does work. Hurts like hell too, I zapped myself before. Good for making the old-fashioned spud guns. Where's my cordless? My cordless has a 5mm tap in it. I need to drive a bit. That's alright, we'll do this the old-fashioned way. Yeah, it's not hard to figure out. Once you understand pressure differential and just the physics of it all, it wasn't hard to figure out how this thing worked. So that could also be pilot ignition. Sorry, that's probably your main on, but that's your pilot ignition, and then it won't work without it. So again, I haven't read the manual. I haven't looked it up on Google, so we'll do this the fun way. I'm not one of these people who looks everything up on Google before they go ahead with things. It's half the fun of it. Exploring and finding things out for the first time. That little slider should move over at one point. I'm guessing once that latches. Once something latches. Yeah. There's a certain point in which that plastic slide comes over and you can actually engage it as running, but it'll only do it after it's lit. So that's done. That's all done. Now, yeah, there's another valve. So if that goes on there, yeah, that's your main on. Once that can latch, you're in business. If you don't get it to the point where it's lit and running satisfactorily, like to its own standards, like everything's working properly, it won't let you depress the main valve. Because again, that's inlet, gas inlet, gas goes through to there, won't let gas through to the other part of the body even unless everything's running properly. So yeah, when you depress your igniter button, you'll temporarily allow gas through, probably through yeah, you'll bypass one of these valves with the pilot on. Once the pilot's lit, then the burner can light, and the burner stays lit. It'll stay open and it'll work. Without any of those combination of things working, it won't do shit. It'll switch off and won't run. So they've pretty much got it nutted out from a safety standpoint. I'll give them credit for that. Screws aren't very tight. I'm using a pissant little screwdriver, which is way too small for these screws, but there ain't no effort needed to remove them. But the gaskets stick very well. I think I just lost half of that. But anyway, you can tell what it was anyway. It was just another valve, which is pushed open by the on button. By that. And there's your pilot pressure from the water valve. Pushes that open when water flow occurs, and you get burning and hot water and all that good stuff. So that part's done. Let's look at this next, after I've had a bit of a rest. Because hunching over this table does your back after a while. Okay, so let's open up the water valve. This is the inlet, outlet and everything all in one. I cannot remember what tube is what, and they're not connected anymore, so we'll have to find out the fun way. There's the diaphragm, which is still partially full of water. Now what would be what? Of course, if water flow occurs, that's what turns the gas valve on. You can see the little pin protruding now. Yeah, so you turn the tap on, that little pin pops up like that. And because there's water behind it, I'd be willing to bet that it's also ruptured. Yeah. Probably not meant to be like that. Don't know, maybe it is. Oh yeah, there's piloting back to the outlet side, so yeah, it does allow some water to get through there, but if the diaphragm's badly perished, then it will fail anyway. But it does allow for some kind of leakage, and that's where that water's come from. It was stuck behind it, but it wasn't impairing its ability to work. So what else have we got? We got something down there, which is adjustment. we've got sitting in the cabinet, that was going out to the bottom of the cabinet, so I'm guessing that's inlet, and you'll have outlet. It's hard to tell without a diagram or any markings. Oh, there's an arrow. So inlet, outlet. Inlet goes through to coil, that goes to the heat exchanger, then it comes back through to... No, that outlet's not used, that's never been used. It goes straight out to the cabinet. So yeah, inlet, outlet, and then out through the heat exchanger without going back through this, because these haven't had fittings on them since it was made. You can tell because they're not clean. Yeah, that's probably part of a different system. It's blanked off and not even drilled all the way through. So yeah, cold water in, flow differential pushes the diaphragm up, turns the gas on, water continues on to the heat exchanger, gets hot and goes out. Job done. And that's just a little adjustment screw in the bottom of it, which is very stuck. A very stuck, corroded adjustment screw, but it's there. Yeah. Simple, effective, lasts fairly long, and this one probably could have been repaired, but who cares, it's just roadside scrap. I've got no use for the damn thing. So that pretty much does it, in a nutshell. Hope you learnt something from it. I know I did. That's the main thing. Huh, it even has Junkers stamped on it. Bosch Junkers, or Junkers Bosch. Yeah, interesting company. Interesting man, Hugo Junkers. That's one to look up on Wikipedia. Let's see if I try not to zap myself again. That works well. It's probably the only part I'll keep. Oh, that and the burner rack for a few experiments till I melt it. Anyway, have fun, and thanks for watching.